Let's go ahead and walk through setting up a new customer master key in AWS, assigning permissions using a key policy, and then testing to see if we can use the keys to encrypt or decrypt data. So I'll go ahead and log into my AWS account, and I will assume a role that has permissions to manage KMS, and we'll call this the KMS admin role. So I'm already logged in. I'm going to assume a role that I've set up. It's called KMS admin role. This role is specifically to manage KMS keys. And I'm going to create a new key. So I'm going to go to the key management service. So I'll go ahead and create a new key. This key will be used for encryption operations for data related to a specific application. So I'm going to choose to make this a symmetric key, and I'm going to choose to have KMS create and manage the key material for me. As you can see, I have other operations here. I can import the key from an external source, or I can use a custom key store. I'll give my key a name. I will choose a role from my account to be able to have permissions to manage the key, which means that they can change permissions on the key or schedule the key for deletion if I choose this option. So I'm going to choose myself to manage the key. Next, I will need to designate roles that will need to be able to use the encryption key. So I'm going to choose ND063 application DDB read role. This is the application role that will be reading data from an encrypted table. So it will need the ability to perform decrypt and encrypt operations on the data. So let's take a look at the key policy before we create the key. So the first section here allows IAM principals to be assigned privileges to manage the key. What this means is that IAM policies can provide permissions to a user or role to perform actions on the key. If this is removed, then the key can only be managed through the key policy by the role or roles who have been designated as key admins. Now, the second portion provides the ability for selected IAM principals to manage the key. In this case, this is the key admin role. The third section provides the ability to select which IAM principals can use the key for cryptographic operations. And in this case, it's the application role. And finally, all the way at the bottom, we provide the ability for the same IAM principal to grant permission to AWS services to use the key. And what this means is that if the application role is interacting with the DynamoDB service, it can grant the DynamoDB service its own permissions to use the encryption key to perform the underlying operations. Let's go ahead and create the key. And it's not letting me create the key because I'm using a different role than the role I had assigned for managing the key. So I'm going to go back, and I'm going to go ahead and change I'm going to go back to the page which allows me to define who the key administrators are. And I'm going to choose this role, the KMS admin role. There it is. Now let's just verify that it's the KMS admin role. Looks good. And the key was created. So this is the key that we just created, and we're going to use this for our application. So let's go ahead and take a look at the two DynamoDB tables that I have created for this walkthrough. I'm going to have to switch from my key admin role back to myself because the key admin role does not have permissions to view DynamoDB tables. Let's go into DynamoDB and take a look at our tables. So I have two tables here, recipes and user info. Now when a DynamoDB table is created, it will use DynamoDB default encryption. With default encryption, encryption is handled behind the scenes by AWS, and we cannot manage access to the encryption keys. So anyone with access to the DynamoDB tables will be able to view the data with this encryption setting. And both of these tables should be set to the default encryption setting. So let's just confirm that. So encryption type is set to default for this table. Let's look at the user info table. And the encryption type is default here also. So I would like one of these tables to use the KMS key that I just created. So I'd like the user info table to use the KMS key that I just created. So I'm going to manage the key from here. And I'm going to change it from default to KMS, customer managed CMK. This is the key that we created. And from the dropdown, I'll find the key that I created. It's the first one here, ND063 application key. It takes a few minutes to update. There we go. So now you can see the master key that it's using is from KMS. So now let's add some data to this table. Right now there's no data in the table. I'm going to add a JSON record with some personal information such as a username and a phone number. So here's some personal information that we want to keep protected. So now I want to prove that this data is indeed secure. So I'm going to switch roles to a different role that has full permissions to read and write data to DynamoDB tables. Now this role does not have permissions to use the encryption key. So this is the role I'm going to use. This is the DynamoDB full. So this role has full permissions on DynamoDB, but it has not been granted permissions to use the encryption key. So as you can see, when this role tries to look at the data in the table, it does not have permissions. And the reason for this is because it doesn't have permissions to perform decrypt operations on the data that was encrypted with that KMS key. It can still read the data in the other table, which had default encryption. So let's see what happens if we have an application that will need to read data from the table. So I'm going to go onto my EC2 instance where I have an application running. I'm going to switch back to my admin user. And this is my EC2 instance where the application is going to run. As you can see, it has a role. I want to change this role to use a role that has permissions to read DynamoDB tables. So this role will allow the instance to use the encryption keys. So this is the application DDB read role. Just to be on the safe side, I want to verify in KMS that that role does have access to use the key. So this is the key that I had created. And as you can see, that's the role of the instance. So now I'm going to log into the instance and try to read data from that table. We use Systems Manager, Session Manager to get onto the instance. So I'm going to use a command from the AWS CLI, and this would be analogous to an application running similar code. And I'm going to try to view the data in the user info table that I had created. I had named the data user info KMS encryption. As you can see, I'm able to list the contents of the table successfully. So in this walkthrough, we have successfully demonstrated the use of a KMS customer master key policy in action. In the lecture notes, you'll find links to documentation and further examples of using key policies and other methods to secure access to encryption keys.